Earth, Moon, and Sun. This is Astronomy, Lesson 3. In this lesson, we'll look at gravity and motion. Gravity can assist us. So we might think of gravity as being something that brings objects down, but gravity can also speed things up. If a space probe comes close to a planet, the planet's gravity changes the probe's path. Engineers plan space missions to take advantage of these gravity assists. A gravity assist can shorten the probe's interplanetary trip by many years. The diagram that we see here shows how a probe from Voyager 2 used gravity to assist and visit other planets. So each time that probe passed a different planet, the gravity of that planet was used to speed it up. So what determines gravity? Earth revolves around the Sun in a nearly circular orbit. The Moon orbits Earth in the same way. But what keeps Earth and the Moon in orbit? Why don't they just fly off into space? The first person to answer these questions was the English scientist Isaac Newton. In the 1600s, Newton realized that there must be a force acting between Earth and the Moon, and it should keep the Moon in orbit. A force is a push or pull. That force that he discovered was gravity. So Newton hypothesized that the force that pulls an apple to the ground also pulls the Moon toward Earth, keeping it in orbit. This force is called gravity. Gravity attracts all objects towards each other. Newton's first law of universal gravitation states that every object in the universe attracts every other object. The strength of the force of gravity between two objects depends on two factors: the mass of the object and the distance between them. So the first law of cartoon physics, gravity will not work till you look down, is definitely untrue. Gravity always occurs, whether you're looking down or not. Gravity, mass, and weight. The strength of gravity depends in part on the masses of each of the objects. Mass is the amount of matter in an object. Because Earth is so massive, it exerts a much greater force on you than a book would. The measure of the force of gravity on an object is called weight. Mass doesn't change, but an object's weight can change depending on its location. On the Moon, you would weigh about 1/6 as much as on the Earth. This is because the Moon has less mass. So the pull of the Moon's gravity on you would be less. Gravity and distance. Gravity is also affected by the distance between two objects. The force of gravity decreases rapidly as distance increases. If the distance between two objects doubles, the force of gravity decreases to 1/4 of its original value. So the longer arrows in this picture show the greater force. If we have two small objects, they have a small force on one another. Two larger objects would have a greater force on one another. Two smaller objects farther away from each other, again, would have a lower force on one another simply because they're farther apart from one another. This graph shows the gravity and distance on a planet. So the distance from planet's center, so 1 would be the surface of the planet where you would stand, and we're relating that to the force of gravity on the planet. And we're measuring the units in millions of newtons. So what we see here is that we have a much higher force of gravity at the surface of the planet, and then as we move away from that planet, our force of gravity decreases. So what keeps objects in orbit? If the Sun and Earth are constantly pulling on one another because of gravity, why doesn't Earth fall into the Sun? Similarly, why doesn't the Moon crash into our Earth? The fact that such collisions have not occurred shows that there must be another factor at work. That other factor is called inertia. The tendency of an object to resist a change in motion is inertia. You feel the effects of inertia every day. When you're riding in your car and you stop suddenly, you keep moving forward. That is an example of inertia. If you didn't have a seatbelt on, your inertia could cause you to bump your head on the car's windshield, or possibly the seat in front of you. The more mass an object has, the greater inertia. An object with greater inertia is more difficult to start or stop. Isaac Newton stated in his ideas about inertia, he called these ideas his first law of motion, and it says that an object at rest will stay at rest, and an object in motion will stay in motion with a constant speed and direction unless acted on by a force. So here's an example of inertia. And another example of inertia. I'm guessing that didn't feel too good. That's why you don't just use the front brakes to your bike. And another example of inertia. So the truck has brakes. The massive hunk of stone behind the brakes does not. And because it's a greater mass, inertia works greater on it. Orbital motion. So why do Earth and the Moon remain in orbit? Newton concluded that inertia and gravity combine to keep Earth in orbit around the Sun and the Moon in orbit around our Earth. So what happens is, inertia tries to keep the Moon in the direction that it is going. The force of gravity tries to pull it back. And these two counteracting forces are going to cause the Moon to stay in orbit around the Earth. Inertia wants the object to continue to go in the direction it's going. Gravity wants to pull it back. The same reason occurs for us staying in orbit around the Sun. So going back to Newton's first law of motion, and talking more about inertia. The boxer on the right, he has inertia with his glove and with his fist. The boxer on the left, unfortunately for him, is causing the fist to slow down. There's a force being acted on the face of the boxer on the left and also the fist of the boxer on the right. So an object in motion and an object in rest, they both stay that way unless they're acted upon by an outside force. And again, an object in motion stays in motion, and an object at rest stays at rest unless it's acted on by another object. I would advise against trying this at home. Football players. That's the reason why it's so difficult to tackle somebody that's running at you and they have a large distance before they hit you. Inertia causes them to push right through you. So just a little fun here. May the mass times acceleration be with you. Just another way of saying may the force be with you.